Hello, my name is Denisa, and in this tutorial I'm going to show you how to build a linear regression machine learning model using Python and the Scikit-learn library. I'm also going to show you how to do exploratory data analysis using seaborn and matplotlib. Linear regression is a supervised machine learning algorithm where the output is on a continuous range, such as salary or price. When people are first learning machine learning algorithms, they start out with linear regression and move on to harder algorithms afterwards. If you end up enjoying this video, I would really appreciate if you hit the subscribe button and you hit the like button, and I look forward to seeing you guys in future videos. For this project, I'm using the e-commerce customer dataset from Kaggle.com. I will link this dataset down below so you can use it as well for the project. Alternatively, I will link my GitHub account below so you can download the dataset from my GitHub, and you can also download the coding file if you don't feel like coding along with me. If you don't have Anaconda installed on your computer, head to anaconda.com/products/individual to install Anaconda. I will be using Anaconda in this project. Let's get started. We are first going to import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT, import seaborn as SNS, then matplotlib inline. And then I'm going to click run. This last line of matplotlib inline, all it does is allows your data visualizations to show up on your page. So now let's go ahead and read the file. df equals pd.read csv. And then I'm going to press tab to grab our file. And this is it. So I'm going to click enter and then run. Now I'm going to type in df.head. What df.head allows you to do is view the top part of your file. So as you can see, each different row corresponds to a different customer. Each customer has an email, address, an avatar, and different metrics associated with it, like the yearly amount spent, the length of their membership, time on the website, etc. If you want to look at the bottom of the file, you can type in df.tail. And this allows you to see to the bottom of the file. Now I'm going to type in df.shape. What df.shape allows you to do is view the number of rows and columns your data sheet has. So in our case, we have 500 rows, which makes sense because we end at 499 and our sheet starts at 0, and we have 8 columns, as you can see if you were to count the columns here. Now I'm going to type in df.info. What df.info does is it goes through each of the columns in your sheet and it gives you the non-null count and the data type of the column. So as you can see here, it looks like all our columns have a 500 non-null count. Because these numbers match, it leads me to believe that we're not missing any data. The email, address, and avatar all have an object data type, which makes sense because if you look at these columns, they're strings. The rest of the columns are numbers, so it makes sense that they're categorized as floats as data types. Now let's do df.describe. Click run. And what df.describes does is it takes the metrics, it takes your columns that have numerical values, and it gives you basic statistical information on them. So for average session length, it'll give you the count, mean, standard deviation, min, and max. And same with the other columns that have numerical values. So take a look at the sheet and explore it more. So now I'm going to type in sns.pairplot and put in df. So don't worry, this takes a while to load depending on your computer specifications or how much data you have. We don't have too much data, so this loaded pretty fast. But if you have a lot of data and you don't have a lot of computer memory, then this will take a while to load. So what the seaborn pair plot does is it allows you to look at different elements you have and their relationships. So if we look at length of membership versus yearly amount spent, it looks like there's some sort of correlation relationship between the two. Same with this one because these are the same two values compared. Looks like there's a little bit of a relationship going on here between time on app and yearly amount spent. So take some time to look through this chart. Now let's create a histogram. So sns.histplot df yearly amount spent. So why am I doing yearly amount spent for this histogram? So let's go back to our chart and take a look. So if we look at our file, these are our metric values, and I want to take these metric values and I want to predict the yearly amount spent based on these metrics right here. And because this is my predicted value from the linear model, that's why I want to create the histogram with yearly amount spent. So I can get an idea of the data distribution. And it looks like most of the values center around 500 and the distribution centers there. Now let's create a seaborn heat map. plt.figure fig size equals 12.7 sns.heatmap df.core and nut equals true, cmap equals VIRIDIS. Then I'm going to click run. So I typed in sns.heatmap, I passed in df.core to get the correlational values, and I typed in ANA equals true to get these numbers to show up specifically on the heat map. The CMAP, this is just me setting the color hue. So as you look at the map, diagonally it's all ones, and that makes sense because this is where the elements are matched with each other, and if it's the same element, it's going to have a perfect correlation. But let's look at some of the other elements on this map. So it looks like length of membership and yearly amount spent have a 0.81% correlation, and the yearly amount spent and time on app has a 0.5 correlation. So this is a really cool map, and take some time to look at this. Now let's do some data pre-processing. So I'm going to type in df.isNull.sum. What this is doing is it's going through all my columns and rows and checking if there's any null values, and if there are, it is summing them up and letting me know. So we got really lucky. This data set has no missing values, but that is not always the case. So if you would like me to do a tutorial on how to deal with doing this project if you're missing data, comment below and I will make a project like that. So now let's go ahead and begin training our model. So let's go back to our sheet, and let me reiterate this one more time. So what I want to do is I want to take these values here, this average session length, time on app, time on website, and length of membership, and I want to have my model use these values to predict the yearly amount spent. So what I'm going to do is I'm going to create an X array, and the X array is going to have these values right here, and then I'm also going to create Y array, and the Y array will have these values here. So let's go and start that process. So I'm going to do x equals df. Actually, hold on. Let's make this process a little bit easier. So I'm going to type in df.columns. And we're going to use these values to copy and paste into our arrays. So now I'm going to type in x equals df dot x equals df. And then what I'm going to do is I'm going to copy and paste the columns I want to use. So I'm not using email address or avatar because they're not numerical values. So for this specific model, I'm only going to use numerical columns. So I'm going to copy average session length, time on app, time on website, length of membership. And I'm going to put those values in here. And then for my Y array, I'm going to copy and paste yearly amount spent. And I'm going to put it in right here. And then I'm going to click run. So now what we want to do is we want to split our data up between testing data and training data. We don't want to use the same data to train and then test on that same data, so that would almost be cheating. So to really understand that our model works, we need to split the data up, and Scikit-learn provides a very easy way for you to be able to do this. So from sklearn.model selection import train test split xtrain xtest ytrain ytest equals train test split x y test size equals 0.3 random state equals 42. So what I am doing here is I'm running the train test split function, and I'm passing in my X array here and my Y array, and I'm saying I want the test size to be 0.3. Test size typically are between 0.2 and 0.4. I'm using 0.3 in my case, and in return it is going to give us the X train data, the X test data, the Y train data, and the Y test data. So I'm going to run this, and let me fix my mistake really quickly. Okay, let's run this again. It should work this time. So now from Scikit-learn, I'm going to import my linear regression model. So from sklearn.linear model, import linear regression, regressor equals linear regression, regressor.fit xtrain ytrain. Click run. So what I'm doing here is I'm importing the linear regression model, and I'm creating an instance of it. I'm calling the fit function on the instance, and I'm making sure to push in my X train and Y train data. You don't want to pull in your X and Y. You want to do X train and Y train because, like I stated previously, we want to train and test on different data. Once you click run, you should see the linear regression right here, and that's how you know it's working. So now let's evaluate how well our model worked. So ypred equals regressor dot predict x test plt dot scatter y test ypred. So I'm going to click run. So what I am doing here is I'm calling the predict function. I'm passing in xtest, and in return it's giving us y predictions. And then what I'm doing is I'm creating a scatter plot, and the scatter plot is going to compare our y test values with our y predicted values to see how close they were. And it looks like they're forming a line, so it looks like it was like decent correlation. So now let's import some metrics to further understand how well this model worked. From Scikit-learn, import metrics. Print MAE metrics dot mean absolute error, and I'm putting in y test ypred print MSE metrics dot mean squared error y test ypred print RMSE np.sqrt metrics dot mean squared error, and then we're passing in y test ypred, and then we're going to click run. So what this is doing is it's finding 3 different metrics for you. The first one is MAE, which stands for mean absolute error. The second one is MSE, which stands for mean squared error. And the third one is RMSE, which stands for root mean squared error. And out of all of these, the root mean squared error, RMSE, is the most popular because it is interpretable in the Y units. So now let's find some coefficients. So COEFF df equals PD dot data frame regressor dot COEF comma x dot columns equals coefficient. So I'm going to click run, and then I'm going to type in COF df to print it out. So what this is doing is it's creating a chart for you for the different coefficients you have in your data. So every time yearly amount spent goes up by 1 unit, the average session length will go up by 25 units, and time on app will go up by about 38 units. So this is a really handy chart. Thank you so much for watching this tutorial, and if you enjoyed it, give it a thumbs up and subscribe to this channel.